let's start. Let's not wait. And let's review where we are and continue. I'll show you what I prepared for today. Take away the video, but don't really need it. It's just to be nice for the first few minutes, okay? So here are our slides. Okay, I need to share the screen. And here are the slides. So everybody has a chance to chat, to talk, to speak. Everything is there. I'm just checking that we have a chat. Where is it?
Today is the last class, right?
No, we have so much more to learn. Today is not the last class at all. We'll keep going. Okay, and as a quick preview is that we are doing a very real class. Some things don't work. That's fine. I actually like a lot when they don't work because that gives you a chance to fix something as opposed to when everything works, it's no fun. So we're also doing a very practical introduction. We want you to come out of that being able to claim that you are a good, well-educated, really know how to do it person. So for that reason, I'm actually re-evaluating whatever I was teaching. When I was teaching, I was always giving people the slides and then the labs, and the labs would usually work because who would bother labs that are not working? And now we're doing somewhat different. We're actually explaining everything. We're giving you a chance to debug your labs. That's real life. So then later on, when you're doing the real life, you will say, well, I've done it, no big deal. So we were right here, and just to review everything that what we have done. First of all, the link to the class. Here's the link to the class, as always. Okay, and that class must have a link to itself right here. So it's a permanent link to this class. Class link. Okay. So now if anybody is too noisy, then I'll have to silence them, but other than that, it's okay. So that's on class, nothing changes. Today we have the next session, section number 4. I'll document it later. Number 4, okay. And I do hear something, so let me check who is that. Not sure who is that. Do you guys hear any background noise? No. Nobody hears the background noise.
Right now, I heard something, but it stopped.
Okay, well, let's go. So these are the necessary links that you have. That's the session that we're going to run today. I'll document it later. Here are the slides. Gradually, I'm changing the slides as well. Right now, we're still looking at the older version, but I'm improving everything as we go. And here it is. So what we did last time is a very simple, here is a user starting an instance. What we did within the instance is that kind of script so that it would respond to our request. We could do a curl or we could do it in a browser way, but in any case, we were creating an instance, and that was the code that we have put in. And the code that we have put it in using the user data. User data is something that you see in Amazon when you start an instance. Now, not everybody actually knows where to even put it. So I'll show you where you would put it so that you know. Let's log into my Amazon account. And then we go into an EC2 part of the Amazon cloud with the servers, and we'll start any kind of server, launch instance. It doesn't matter what we start. So we'll start the simplest possible Amazon provided instance. Here, it's ready to go. Instance detail, and here, down below, in advanced, there is this user data. So most people, I don't think they ever noticed this. This is where you would put the script. So if you were doing this manually, here's what you would do. You would put the script which was shown in the slides. It would be that script. Okay. And now in our case, that script is given to us on the labs. Let me show you where those labs are. Okay, that's all in the labs now here. And let's start with the simplest possible lab. It will probably already have that. So that's the user data. So what I need to put in the user data is not all of that, because EOF and EOF here, that is just the notation of Terraform. But what I need to do is just this, that's all. So if I were to start an instance like that, I would put it in there. And it would then run on startup. Now that is not how we're going to do it. I'm just showing you that's what you would do if you were doing it manually. But let's stop this for now. Let's continue with the slides. So that's what we were doing. That was the Terraform way of giving it to Amazon manual script. And in here, we also had to create the security group. So we created the security group. We said it should allow all traffic on 8080. And then we said, now let us run. Now we also use the expression. We said that if we want to use a certain parameter, then we can pass that parameter to our Terraform, and then it would look like this. Here is an AWS security group, which we get from the security group instance ID, and in this case, we were saying that the VPC in which we're running is that same VPC which was mentioned in the security group. And then suddenly I realized a very important thing. So that all worked, we were adding instances. I realized that not everybody can actually do it manually, that I absolutely need to add one more lab. In that one lab, we're going to do this construction manually, okay? And then we're going to do the same construction in Terraform. Now that becomes complete. That's the problem with most of the ways of learning, is that you assume some knowledge, and very often that is an incorrect assumption. So what I prepared for you today, and we stopped right here, it worked, but we didn't quite really understand why it worked, even this hello world. Here's what I have for you today. So that's where we were last time. We did this lab, we're ready to do this, but first I need to give you lab number 1 for today. Here's lab number 1 for today. It's under labs, and it is preparation for the third lab. Okay, so now here we're going to work with the load balancer, and we're going to do it in a very simple way. We'll create a couple instances. We will connect the load balancer to those instances, and we will verify that that all works. Again, for some it may be too simple, but I believe that there are enough people who don't find it too simple. Now, if I am able to do the polling, questions, right? How do they do this? Boy, that is so complex. No, I'm just going to ask, who can do the load balancer in their sleep? Okay, now you can tell me if you know how to do it real easy and well and perfect, then tell me. Nobody, look at that. And who cannot do it as yet? Now that's better, right? And I see some raised hands. Awesome, so that makes sense. Here is the lab that we're going to do. But I want to walk through that lab and I want to do it for you now. There you are. All right, so that is the picture that we're doing. We'll create a couple instances. We'll connect them through the load balancer. And we'll just verify that that all worked. So first of all, general steps. First of all, we will log in into an Amazon account. Now, what I'm doing here is a more realistic lab than what you would get when, let us say, quick lab. I'm not giving you too much instructions. You know how to log in into Amazon account. Then I will also ask you to create a security group, which will allow the traffic on port 8080 from anywhere into our instances. Then we will launch a couple instances. And don't worry, micro instances at about 1 cent, I think 1 cent, maybe 2, 3, an hour are enough. And of course, we'll kill them later on. So we'll use the key and then we'll go inside and we'll run that script. So that script is what will allow us to verify the instance. Then we'll verify it with curl and verify it in the browser. Then we'll create the load balancer and we'll verify that it works even that way. Now, if you want to do a bonus, you can keep playing with this and observing how it should be routing traffic to different instances. So it's up to you. One of the ways you could do is one instance should respond in one way and another in another way. You'll see if that really works. If you want to then load it with JMeter, that's awesome. But those bonuses we're not going to do now because you can do them at your spare time. So all we need really to do is the first 6 steps. So that doesn't take all that long. We're creating the load balancer right now manual. This is a completely good question. This is a completely manual lab for those people who don't quite know that. And it makes sense. First, I need to show you how you do it manually. And then I need to show you how you automate it with Terraform, right? So here's the lab. Let us start. Here it is. And if something doesn't work, you'll help me. So here we are. I'm trying to move that thing away. Okay. Here it is. What I'm doing is I'm creating a couple instances. That's how I'm doing it. And you don't have to do it just yet because you'll do it on your own. So, okay, I select an instance, very small. Nano could also work, but okay, we'll stay with micros. Configure the details. We need 2 instances. We want them to show into the world, enable the public IP, and that's all we need. We're not using this user data just because we want to touch everything with our own fingers. So add storage. We're not going to really use it. All we need to do is run a little script. So the default 8 GB is good enough. We'll add the label. So let's call it class demo. And the security group. Now, I believe that in my case, I probably have a security group. But what I want to do is create a new one just for you because you probably don't. So I'm calling it a class demo security group and allow 8080. Okay, so it got a security group. Okay, and I think I said 2, didn't I? 2 instances. So that's all I really need. Let's go and create them. Now the key. Now here I have a certain key. I'm going to use a key H1. You guys, if you don't have one, you will instead say create a key pair and it will create a key pair at this point. I'm using an existing one. And yes, I understand that I need to have that key at my disposal. Well, these are small standard instances. They should start pretty fast. So let's look at them. Okay, so I have a class demo, couple of instances running. Now, the next step is I'm going to log in into them. How will I log in? I'll take that address. Here's everything about that instance. And here's its public IP. Okay, so I will copy that public IP. I will open the terminal like this. I'll make it bigger so that you can see what I'm doing. I'll check that I have my keys. Let's .ssh, right? And I have this H1 key right here. Okay. And so I can do SSH minus I dot SSH HI1, that's my key, and the IP. Now, oh, sorry, the IP. Now let's look at that IP. It's right here. It's initializing. So let's take this one, take that IP, and copy it right here. And then that shouldn't work for a couple of reasons, because I didn't give it a name. I need to give it a name, and because it hasn't started. But let's try. So here we are. Yes, we want to get there. And it says you cannot get in there. Sorry. So what I need to do is I need to give it a name. Well, I know that all those instances are called Ubuntu, and if it is initialized, then it will let me in. It is initialized. It did let me in. So it should be nothing there. My next step is to take that code that I want to put in there and actually put in there. That's what I want to do. Here's our lab. That's what we're running, right? And the code that we're running is this. So I believe it doesn't format exactly right. I'll show you what I meant. So we'll create a little file called run.sh. And we'll put this into this file. Now it's squished. Those two lines, what we really meant is that first there's a bash, and then there's an echo, and then I believe I not need to do no hangup. I'll fix that, but you can see what I meant. Okay. Now I save that, and I try to run it, and it doesn't run. That's because I didn't give it the run permissions. So change mode plus X, run. Now it will run. So I do this. I say run. Okay, it says I opened. So now if I do curl on localhost 8080, I hope to see something. Well, I didn't. Well, because I didn't say localhost slash. Local L host, right? Okay, that worked. Nice. Now I need to test it in the browser. So I'm going back, checking what was my IP. Well, my IP was this. That was my IP. So if I go into the browser and I check that, 8080, then that doesn't work. Now let's check first of all that I got the right thing, and then I need to check my security group. So here it is. It says security group class demo, and the security group might be good, but I forgot to add 8080. Great. I promised you lots of mistakes, and that's where you learn. So I need to add a rule, and it is custom TCP on 8080. Okay. And it should come from anywhere. From anywhere, and save that. So now we have that security group on 8080. Now let's check our instance. Will it run now? Still doesn't. Well, let's assume that maybe the security group is initializing. We were right here. Ah, it worked. Magic. So here it is, right? And we have hello world. Now, what I will need to do is create a load balancer. So I'll go right in here. I will go in here, create a load balancer. I'll do it here. Load balancer. And create a new load balancer. And it will be an HTTP load balancer. So I need to give it a name. So I'll call it class demo. Not sure what is load listener. I have one. It's HTTP. I don't need this one. All I need to do is 8080. Tell it to go from 8080. I will assume that 2 availability zones are enough. Okay. And I'm looking for where do I tell it what to run. So configure security group. That's a class demo security group, this one. Okay. Configure routing. Now it's an instance. So I need to tell it that my targets are, I need to give it a name. So it's a class demo. I'm inconsistent, sometimes with a dash, sometimes not. Now, which instances do I want to run? Well, let's look. What are their names? Class demo, all right? So it's this one and that one. Now, I only really initialized one. The other one won't respond correctly. And now I create it. So that's it. Now then, later on, when it is created, I need to look it up, find what is the IP for that class demo, and try to see if it will really lead the traffic. But that is our first lab. So what I'm going to do is give you that lab, let you do it. There you are. And then we will compare the results, and whoever wants to brag about what they did, he or she is welcome. So lab 1 for today. And I'm here to help you, and you can share the screen. And so you see what we end up doing is first learning how to do that same infrastructure, but now that same infrastructure is coming to us manually, so that we understand exactly the infrastructure that we're building. Later on, we might want to do more things. For example, we might want to do on Google, on Azure, wherever. So first, we need to run it manually, and then we need to automate it, and then we will be really expert administrators. All right? It's all yours. Okay, and I have lowered all hands, so whenever you are done with that lab, you can raise your hand. Whenever you have a question, you can chat or you can talk. Now I took a wild gesture of allowing everybody to talk. But I'm trying to mute it back. Yes, Paul, instance will be starting for about a minute or two. It's not that bad. Bigger instance, they will take even more, but that's the nature. That's the nature of those labs. They do take a little time, precisely because each individual part works for a while. Okay, how do you install the BusyBox? That's a great question. I noticed that my formatting was not perfect. So let me do this. I'll push a better formatting and you will see exactly what I did. Okay, so let us go into our lab, which is found right here, and let us refresh. Okay, and now it shows in the beta format. Here's what I did. You launched the instance, right? You logged in, and I hope that worked. Then in each instance, you can create a little run.sh, which will look like this. This run.sh you will be able to run. You'll make it an executable, and then you'll say ./run.sh. That I believe is exactly what I did here, right? So if you look at the history of what I did, at a certain point I said .run.sh. Since this is no hub, no hang up, then it runs by itself and it doesn't interfere. Here it is, it goes in the background. And if I do the curl command, localhost on 8080, and it does hello world. I can go a little further. I can go here in the instances. Find one of them. I hope it will be the right one. That's this one. And now if I say curl and give me that URL on 8080, let's see what happens. Same thing, right? So it really is working. It's giving me the response. That was your question, right? So you must use Ubuntu image. Well, yes, I'm using Ubuntu image. You can guess that by saying that the username is Ubuntu. If we go here, then I should have said it here in the lab and mentioned when I say login, and I should mention that most of the Amazon images are accepting either this or another name. I'll edit it right here. Okay. Launch, login. And so keep in mind, so it is either Ubuntu or EC2-user as user names. So if I save that now, at the very bottom, then our lab instruction will be more complete, giving you this additional information. And if you refresh, you will see it as well. That was your question, right? You're welcome, Henry. Okay, another question, Paul. It needs 2 availability zones, but your 2 instances are in the same zone. I believe that's okay, because the purpose of those instances is twofold. First of all, what is the traffic? So let us say you have a huge load on one instance. Yes, it is in the same availability zone, but the whole purpose of the load balancer is to take some load off your first instance and shift it to the second one. So I think it's all right. But the load balancer wants 2 availability zones. I gave it 2. I'm not sure. I really don't know why it insists on 2. Okay, it could be the best practice because you're right. We should have done it in 2 availability zones. Doesn't cost you anything at all. Yeah, that probably is the answer. Or it actually insists on that. That's very interesting. I wouldn't insist on a best practice. You cannot do it with one AZ. So RJR done, right? I understand your raised hand as you've done. Okay, great. But we'll give people more time. Now, it's not that important to complete it, because if you work that long on that lab, you probably begin to understand it, even if you don't debug it. That was always my experience. All right, something doesn't work, so it will work the next time. But we'll give people, let's say, maybe 5, 10 minutes. By the way, RJR, I don't know how to say your name, but will you mind if I ask you to go through your solution and share the screen and show it to us? Good question. That's for Ram. There shouldn't be any password. The way you log in is by saying SSH minus the key. So let me show that. That's how I was logging in. I will add that as well.
Okay. Thank you.
Okay, and I won't add it. Okay, and don't worry. Right. Anybody who wants to demonstrate it is very welcome. I wonder if we need this here. So here's our lab. I'll fix it later. I need to give that a little instruction on logging in. Well, let's fix it at least a little bit. There you are.
Excellent.
Okay, the IP of the balance is a good question. I believe it's here. So here's my balancer. Let's look at the balancers. Okay, and here is the balancer. Now, I believe that is the DNS name. I'm not 100% sure. Copied right here, and then 8080. Let's see if that works. Okay, so that's what I got. That's something that bothers me now. That's not right? It shouldn't be like that. But in any case, it is the right IP, and it responded right away. Try yours. But RGR, for you, it worked, right? It worked completely, and it showed you the right response, correct? .503 means insufficient capacity in the load balancer. That is very strange because all I'm asking is just one response. But what it want to say, perhaps, is that one instance is not enough. I cannot believe that. In any case, that's what the documentation says. They talk about how you can debug it. Okay, so RGR, you're saying initially you didn't add the target, but then you added them and you got them. Okay. Okay, let's do this. I think that was a good workout, and for many of the people it worked. And if it didn't, well, there are ways how to debug it. So let me ask you that question. Is that okay to go on now? Nobody answers. Why is that? Yes, all right, Louis. Thank you so much. Let's do this. Let's continue. I'll tell you what I want to do now. So here's where we are. And we'll talk about a more real life situation. So I'll show you what I want to do, pretty much the same as what we've done. We have done 2 instances and the load balancer. What I want to do is auto-scaling group and the load balancer. Now, what I'll do will be more right way to do things. And so let's go. So first of all, a note that what we're making is a completely open situation. We can get to every one of our instances from the outside. That's what we have done. If we look at our situation, here is the first instance, running instances. Here they are, but they're all open to the public. Here is my security group, outbound rules. Well, we can get to anywhere from anywhere, right? Well, in the real world, that's not what you should do. You should start them in a VPC, and then only your load balancer will be visible to the world. And from the load balancer, it will be going into the instance. I'm not drawing the diagram, but it's pretty clear that you have only one much smaller surface of attack, only one IP out. That's a note. Now, what we're doing now, once in a while, we're using variables. You have already seen how we do it, but we're using this principle of don't repeat yourself, dry, that we shouldn't be putting 80-80 everywhere. To do this, we're using a variable. Now, we're saying that's a variable, then we give it the description. It's just a documentation. It's always a good idea to tell people that's what I'm doing. It's also a good idea to give the default so that if they don't want to supply that variable like 80-80, then they will get the 80-80 anyway. And finally, the type. A type is not that important. We can just do the string and that's all. But it's better programming practice so that if you give the wrong type of parameter, then it will complain. So it includes all of the best practices. Practically, that's what you would say. Let's say you want to put a number. Here is a variable. I'm calling it a number example, but really it should be whatever number I need. And then you're saying that's what it is. The type is a number and the default is 42. So it will really work as the default 42 and as a type number, and it will verify that what you're giving it is the right type. That's one way to do the input variable. Here's another one. You can give it a whole list. Let's say you want a list of instances in different availability zones, would be a good example. So you're saying, here's an example of a list, explain what it is, and you're giving it the type. It will be a list of numbers, and then the default. Now, you can even give it a map. So you would probably say, for AZ1, that's what I want to give you. AZ2, that's what I want to give you. And you immediately recognize that it could be very useful in different clouds. Now, the next one is, here's a whole object. The whole object will have quite a few things. It will have a string, a number, a list, and a boolean, whole 4 things, and then an example of what it could be. That's the default of value 42, ABC, and true. So you can have a very complicated variable. And in our particular example, what we're doing is saying, here's the server port, and it's a number. We didn't give it the default here, so we had to give it an 80-80. Now, in our code, we will then use it. We will say var, that's for variable. In other words, the compiler will look for the variable called server port. And where did we call it server port? Right here. That's where we called it server port. And now we will need to enter the variable by either just when it asks, we will enter the variable, or we can do this like that, or like that, or like this. Now, we should have done it last lab. I'm not repeating this. I'm just reminding you that that is how you use them. And in the lab, you were supposed to try every one of those ways and verify that it still works. Now, we're using that variable. For example, we're using a variable called var server port, and this is 8080, so it says from port to port 8080. Now, this is, you recognize, is exactly the EC2, which says forward from port, let's say 1000 to 1005. Now, sometimes you need to give the data. So that is how you give the data. We're giving that server the user data, and that user data is something that Terraform recognizes and passes it to Amazon. And then Amazon gets exactly that. So you did it manually, and you used this variable with the server port. But in our code, we're going to use it in the code. Now, you may want to do some additional variables, output. Output variable just simply says, and when you have finished your work, then tell me what is it that you have constructed. So the most common variable is the IP of the infrastructure that you have constructed. But there is also a parameter which says this is a sensitive thing, don't ever log it. So it will stay as much private as it possibly can. Okay, now here's the output. It's an example of the output, and that's what we will really use in order to check. We're going to build pretty much the same structure. We'll build a few instances in the back end. We'll build the elastic load balance in the front, and that will be the load balancer output. Now, in this case, it's just some instance output. So that's the lab that we did. But now we're after today's lesson, which is adding scalability. So here's what we're planning to do. We're planning to use a lot of servers. When you started your instance, let's do it again. When you were starting your instance, and you chose any one of them, but you said, I need more than one. Let's say you said you need 3. You'll get a warning. Let's go. Your instance will be launched. Here, well, I didn't get a warning. But before I did get a warning, and that warning was saying, hey, you're starting 3 instances, why don't you put them in the auto-scaling group? Of course, it's the best practice, true. But keep in mind that Amazon will gain, because if you put it in auto-scaling group, well, it will run as high as it possibly can when you need it. So it is a good practice, and that is what we will do. When you use an auto-scaling group, then they all work all in Concord. The load balancer goes to every one of the instances in this auto-scaling group in that particular VPC, and it measures the performance or specific parameter which you will tell it. You'll say, I want to measure this or that, and if it goes below, then the load balancer will not even send the instance through that traffic. So it works exactly as you would expect it. This is what we're going to build. We'll build a load balancer right here, the auto-scaling group that is found right here. And to create the auto-scaling group, we'll do this. We'll say if you create an auto-scaling group, then the instance that you should use is this. AWS launch configuration, that's the instance type that you'll be using. So every one of them will come up exactly like that. You will also give it the security group into which they all are being placed. And so that's what we'll put here. We used to have a different security group, so now we're putting this security group, and each instance will have that in its initialization, so they will all come up as web service. Now here we're saying, and here's the auto-scaling group itself. So far we created the instance, so now that's the group that we're creating. So that mostly consists of description parameters. We call it an auto-scaling group. In our later code, if you want to refer to this, you will call it example. Not the best possible name. We could do something better. And here is the instance which you are launching, the scaling group. That's the one that you are launching. And by the way, they use the example also there as well. Now, the minimum number of instances is 2. So it will come up with 2. The max is 10, so it will never go above 10. And who controls that? That's your load balancer. The load balancer will watch the traffic on each, will watch the load, which you set. You say, you increase it when the CPU is more than 50%, something like that. And here's the tag that you need to put into the instance, and that's just a description. So the tag will go under the name. In other words, here, if we're looking at every one of those, then this is the name right here. That's that tag. So it will be under name, that will be the tag, and propagated launches through. Then you want to say here is what you do when you are destroying this. And Terraform will invert the number in which it replaces the resource, create the replacement resource first, and then delete the old resource. So that is if it wants to recreate that particular group, then you will create a new one, destroy the old one. Now, one more parameter, subnets ID. So far, we didn't use it because all of our instances were facing the public. But the subnet ID tells the ASG, the outer security group, into which VPC subnet it should be deployed. And then it will stay into this VPC so that nobody will be able to get to that from the outside, except by the way of the elastic load balancer. So a better use practice is deployed in different subnets, and that will be fault tolerant, right? And then you can get which specific subnets, you can get it from data sources. So what is the data sources? That is something that AWS will give you every time that you run Terraform. So the data sources is your way of querying the API. You will get the VPC data, the subnet data, the AMIs that are available, and the ranges, and so on. In other words, that's something that we will see in the dashboard, but given to us in the resources. So here's an example. That is how you will get the data, and that's how you will provide the VPC. Okay. Now, here's the way of getting the data sources and then assigning, in this case, the default, but in other cases, you'll be assigning a specific one. How do we use it later on? We give it the subnet ID default ID. That's the VPC verifier, and we'll be launching here in this VPC, and we will also tell it that the name will be Terraform ASG example. So we're almost done. Now what we need to do is build it and add the load balancer. So how do we add the load balancer? We have multiple servers. All we need to tell the load balancer is that here is where you grab your instances. Now, there are quite a few different load balancer. We're using the application load balancer, which simply goes into the HTTP or HTTPS. There are quite a few others, as you can see, network load balancer and classical load balancer. So we'll choose one of them. Okay. And here's an application load balancer. That's the one that we're using. And that's how we're saying that's what you need to do. The type of load balancer application, that is the subnet from which you're getting your instances, and that's where you yourself will be residing. Okay, so the ALB listener, it needs to know how to measure what's going on its instances. So it says, I'm accepting traffic on port 80, for example, and my actions are fixed response. So if it is response is text plain, and it shouldn't say page not found, because otherwise I'll give the code of 404. Now, then we also need to create that same security group in where we started all of the others, because they are measured by the same IP. And then we need to just give it our LB, give it that right security group. So now everything that what we were creating manually, it's now being automated. And here are the limits. We're saying that is what we expect. We'll be checking the health every 15 seconds. We'll be giving it a timeout 3 seconds, no more than that. We'll say that the health threshold is 2 seconds, unless that is really milliseconds. That's something we would need to check. But the end result is that we got a complete system. Now, the target group is to check the health periodically and verify that that particular instance is good. If it becomes bad, we will get a warning. We'll drop that one. We'll start another one. assuming that the problem is really just on the load. And we'll start sending traffic to the other one. The load balancer will be sending it to the other one. So now the target group, it knows where its instances reside. So that is what it will do. It will say, I am an auto-scaling group. This is my VPC zone. That's the target from which I'm getting my instances. That's the health check, which has already been discussed. That is the size of my auto-scaling group. Okay, and finally, the listen rule. Listen rule says I'm listening on every, on the port that I'm given, I'm forwarding it to another instances on the same port. And finally, the output. When L is done, we have to create this, and we have to see that our final target is this. So that will be what we will output as the result. And with that, we should see that. We should see a few instances. We should see a few instances, and we should also see the load balancer. Okay, right here, we should see that load balancer. And then we should try it. Okay. So now I prepared the lab for you. The lab is here. I'll show you which is the lab. It's this one. So let's go through that lab. Then I will ask you a very important question, and then you will do the lab. So here's the lab. What we do is we prepare a project. In this case, you do it in any folder that you like. So you will create, let's say, a folder with the labs. So let's go into our terminal, and let's make it bigger. And let's make a directory called my labs, maybe. And let's go into this directory, my labs, and make a directory for the lab 01-3. Okay, so let's go in there, and there's nothing there. Now, what I really need there is a main, right? So there will be main.tf for Terraform. And now I start running this code. So first of all, I'm telling that Terraform needs to be between version 0.12 and 13. So here it is, I'm saying this. Okay. Then I'm looking at where will I run. So that's where I will run. Okay, so that's good enough for now. I want to check that if I do a Terraform here, and let's say I want to plan, what will happen? It will say, you didn't do anything as yet, you need to do a Terraform init. So let's do this Terraform init. It downloads everything for the provider, AWS. Okay, and now if I do the Terraform plan, it shouldn't complain. Except that it says, well, you haven't told me anything that I need to do. And on and on. So what we're doing is, first of all, we declare our additional parameter for the port, which will be 8080. We now create what kind of AMI we're going to be launching in our SG. So it will be this AMI and that security zone, which will come later, with this thingy running as a user data so that every one of them will be first initialized with the script and become a web server. Then we will prepare the VPC, the virtual private network. Well, we will use the default one. So that's the one that we will use, and that's the subnet IDs that we will give. Then we will set up our auto-scaling group. Okay, and that's what we're saying between 2 and 10. And here's the subnet in which we create this one. Now we're creating the load balancer. Okay, that load balancer will react with page not found if there's nothing. Then we're creating a security group for that load balancer. And then the load balancer itself right here. The load balancer should have these parameters. We went through all of that in our slides. And in our security group, the server port will be that same server port right here, which we ran. So we'll be on 8080. And now with that, we'll be able to save it all, try to plan, try to run. If you want bonuses, here are the bonuses. You can try to see that if something doesn't work, let's debug it. Now you'll be able to log in, check every instance, verify that it works, check why is the load balancer not working if it's not working, and then do some more. Try to do some JMeter and see how high can you run the traffic. That's a huge lab. I don't think that we will do all of it, at least not the bonuses, but we will definitely do the lab. Now, before I give you the lab, I want to ask you a question. You see my screen. You see what is going to happen. That is what we should learn about step by step. So right now, we're right here. Okay, our next step could be, well, exactly how does Terraform check its state? Somehow it works magically right now. We are saying, please plan. It compares what it has to the real infrastructure and goes back. That would be the next step. But if you don't know how it works, well, it's not a tragedy. So this is kind of optional. The next one is, well, so far we're running individual structure of infrastructure. Well, what if somebody already has their own module well debugged and developed? Can I use that? How am I going to build a whole library of reusable infrastructure? Then we want to talk about more language elements, how exactly they work. Then about how do you build a real scalable deployments? Then how do you test? Here. And finally, what if you're working on that in a big team? So if we go this way, then we will gradually know more and more of Terraform and will become really deep deployment architects. That's way number one. Way number one, and I'll put it here in chat. Here is chat. One, follow the order. Two, well, perhaps we want to run it on another platform. Perhaps we want it on Azure. How do you do the same basic things in Azure? And three, how would you do it on GCP? All right, now that we have those choices to think about future direction. So who the people who think that we should follow the alternative one? Could those people raise their hands? 1, 2, 3, 4, 5. Okay, 5 votes for one. Let me erase that. Now, is there anybody who is a lover of Azure? One, two. What about number 3, GCP? Oh, wait a second, I didn't allow all the hands, now do the GCP. 1. So the vote is we should continue learning about Terraform, going deeper and deeper, and then consider Azure, and then consider GCP. At least that's what it is right now. So I'll give you the lab to run. It's exactly this one. And I urge you to invite your friends. If you know somebody who has kind of nothing to do, let him join us. As you can see, you don't really need any background. You don't need to listen to the previous lectures. They're all available, but you don't need to. You also don't need to know anything about anything. We'll show you. And you also can follow the book. The whole course is based largely on a specific book. You can easily find this book. There is no hiding. It's that lab that we're using. It comes with this book. Now, I'll show you the book. I'll give you the link. And I recommend to buy it anyway because it's a great book. That's the one. Okay, so that's a real book. Let's take away the extra information. I think we don't need any of that. It should still give us the same book. There you are. Okay. Book. So if you tell your friends that we are having a wonderful working hard real workshop and it's based on this book, fine. And we're working way deeper than any page would give us, then that will be great. The more people, the better the learning. And now you can all start the lab, and I will clean our hands again. And when you're done, you can tell me I'm done. Okay, guys, so I'll say goodbye to you for this time. We'll be talking next time, and I expect all of you to come back and work harder and more, and also to bring your friends. Okay, thank you.